Hello everyone, it's March 17th, so finally we can do one earlier. Alright, let's do this. Minimum arrows to burst balloons. I think I remember doing this. There are some special spherical balloons taped into a flat wall that represents XY plane. The balloons are represented as a 2D integer array, points where start end denotes the balloon whose horizontal diameter stretches between start and end. You do not know the exact y coordinate of the balloon because you don't have to, if I remember correctly. Arrows can be shot up vertically from different points along the x-axis. A balloon with its start and end is burst by an arrow shot at x if it's within this range, right? There's no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons. Yeah, so given the point, return the minimum number of arrows that can. So basically we want to find out the which balloons are overlapping, right? That's basically what this is. We need to find out the overlapping ones. And then usually for this type of problem, you will sort, right? You sort based on, so actually we don't even need a y-axis, right? All we need is just x. So we have this one 0, 1, 2, 3, 4, 5, 6, da 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 da. We can do a 10. Well, I need an 8, and then we need a 16. Okay, so it's a 2 to 8. Jesus, 2 to 8. 1 to 6. Okay, 1 to 6. 7 to 12. So I have 7 to 12. So 7 to 12. This is 12, and 10 to 16. Okay, so yeah, you need 2 arrows, right? So basically, we sort based on the starting position. Okay, so we have a bunch, and then you just say, okay, this is my start, and then you see the second one, does it have overlap? That's most likely a method of greedy, which is saying we're gonna try to do as many as we can for the current one. Will that be optimal? And let's say for the first one, we try to find we try to stack as many balloons as possible for the first one, right? And then once we handle those, and then for the next one that's not been stacked, we try to stack as many as possible for that. So that's kind of one way of solving this. Now, is that going to be optimal? So let's say the first one is only overlapping with one other, and then they're overlapping, just barely overlapping. So if we shoot one arrow, it's going to pop 2. And if this, yeah, I do think that is optimal, right? I mean, otherwise, all right, let's try to say the second one. Second one, we have 1, 2, 3, 4, 5, 6. Yeah, that's okay. That's stupid. 1, 2, and then 2, 3, 3, 4, 4. Yeah, 1, 2, 2, 3. That's 1. 3, 4, 4, 5. That's another one. So I do think we can just greedy, right, to find how many is overlapping with the first. Yeah, we sort first and see how many is overlapping with the first one, and they will all be shot down with 1, right? They have to be overlapped with the first 1, 2. And because if you don't do that, right, if you say, okay, if I do that, I have a better way. Like if I don't pop all the overlapping one, and I say that can make a better result. That means you have some that can be popped by the first arrow you choose not to, right? You choose not to, and if you choose not to, you say I'll do later. That can make it better. If you do it later, but the first one needs to be popped no matter what, right? The first one needs to be popped no matter what. So you're gonna have to spend 1 arrow on the first one, and then the one you don't pop will be popped later. And you say that can save. I don't see how you can save, right? I don't see how you can save because whatever one you saved that you don't pop, you have to pop on the second arrow, right? You have to pop on the second arrow. And for the second arrow to pop you, if it doesn't affect, right, then what's the point? It doesn't really matter if it pop in front and pop in back. And if it affects, yeah, so if the balloon you choose not to pop now, right, and you have to pop later, and if the later can pop, then what's the point? You can pop front, you can pop later, it's the same thing. And if the later, well, you cannot pop it, then you have to spend one more arrow to pop it. So yes, I think I am convinced that this is basically, we're just going to, you know, try to find all the overlaps. Man, I just finished the training and then my hands are still not feeling well. Man, I definitely did way too many snatch today. Way too many snatch. Because I think my technique just, I guess I'm not really talented in doing this because the technique just regress, you know? I had good techniques for a while, but just for whatever reason, it just doesn't work anymore, right? Anyway, so what we're gonna do is we're gonna take the first one, right? And then we are going to, for each one, we're gonna compare. We're gonna compare the start. If the next one's the start is smaller or equal to the current one, the first one's end, and that will all be one arrow. And until it's not, then we reset it to a new one. And then, yeah, okay. So what we need to do is I need to have an index. So int current index, okay, should be 0. And int res is also 0. And then we say for int I is 1, I smaller than points.length I plus plus. Let's see if this works. Maybe it doesn't work. Yeah, it's likely. And we just say if points I is the starting point is smaller or equal to, okay, no, if it's larger than points current index 1, okay, if that's the case, then res plus plus, we need to add an arrow and current index equal to I. Otherwise, we just keep going and then we'll return res. Let's see, that's all right. I cannot sort. Do I need to say comparator? Hold on. Do I need to say comparator dot comparing int current p? We do p 0. Do I have to do something like this? Is this what we're looking at? Yep, it is. But it's not right. Oh, that is fantastic. Okay, so what happened? Well, in the first one, I have this first, and I say it's 0 is not larger, so we keep going. And then here, it's larger than this, and then res plus plus, yes, and current I equal to this. And then we go to this one. Oh, I forgot to. Okay, so at the end, I have to return +1 because the last one, right? The last one. I always forget about the last one. Okay. So let's hope it's correct. Every time you do greedy, it's always feel like, you know, is this really correct? Greedy. Try to find as many balloons as possible that overlap with the current one under, not current one, the first one. How should I say? Current one under consideration. Once the overlap ends, we reset the current balloon, right? And increment into the balloon, and all the previous balloons will be popped by one arrow. Okay. Ooh, I forgot this +1. All right, let's try this. Let's throw one more. Something like this. Just throw one more. Ooh, negative. I don't think negative will matter. I think we can just go straight for this one. No, it's wrong. That doesn't work. Holy crap. All right. That was, yeah. That was not. Interesting. So that was not right. Huh. Why? Good question. All right, let's see this one. This. Okay, so if I want to do this, we sort, we have 0, 9, 0, 6. 0, 9, 0, 6. I only consider the 0, 9, 0, 6. I should put 0, 9 first, right? Okay, how do I do the comparator? I need to write a. Can I write? Damn it. Yeah, I should. Yeah, I know. Or I will do something like this. Not current int, so current right. Okay, equal to 0.01. Then we say current right, so equal to .I1, and then this we say else. Else we say current right equals to math.max current right. That is actually not right. That is not right. No, I don't like this. I do not like this. I do not like this. What I want is still get a. So do we have something like this? Can we do, P1, P2? Okay. Actually, I don't know. So Java array sort custom. Alright, I have to use a. Oh my god. Is there no simple way to do this? And the thing is, I just never remember. I never memorized this. New comparator integer. Int compare. Two things, and then we can do the compare to. Okay. Okay, I'll do it that way. Like, how complex can we write this? That's my question. I just use this comparator thing. New comparator integer. Okay, I'll oblige. I'll oblige this. So we're gonna do new comparator integer. Actually, is integer? It is integer, right? And we say, oh my god, public int compare, public int compare, int p1, int p2, right? And then we say if p1 0 is equal to p2 0, we say return p2, no, integer dot compare p2 1, because I want to reverse, right? p1 1. Otherwise we return integer dot compare p1 0, p1 0 and a p2 0. Alright, let's see. I'm not very sure, and then every time I try to do this type of thing, there's a high chance that I got it wrong. Just want to do like a complex sort. It's not abstract. It's not override abstract method. Compare and comparator. Okay, so that's not the syntax. Oh, I have to do it this way. Damn it. Nah, actually, I actually want to know. Yeah, this idea of boxing and then stuff, it's really hard for me to understand. Actually, I mean, it's more is I don't want to understand. Oh yeah, I have to be an object, right? It is an object. Oh, maybe it's int this? Is this what? Is this right? Okay. I'm not sure how this one's sorted result is. Okay. So in this case, I need some debugging capabilities. Do we have a debugging? Oh, I don't even have this. IntelliJ. Need a debug, unfortunately. That's okay. I'll just debug here. Okay, and we're gonna put. Let's put it here, and this is gonna be. Oh my god. Okay. I definitely do not like this. What's this? New int. Okay, and what we need to do is, oh lord, Okay. Replace. Okay. Next is to find this. I'm going to replace with this. Okay. We don't need this. This is find this points. Okay, let's debug this. Okay, and take a look. Points 0906. Okay, so 0906. 2 included. 2 includes 3, 3, 3, 6, 7, 9. I don't know why my answer is. Oh, because you add. Oh my god. Oh my god. I know why. Okay, so under what circumstance do we add 1 at the end? So I know. We don't add 1 here, but we set this to 1. So the first arrow already shoot out. Oh no. Now what goes wrong? Oh wait, hold on. The answer is 2. Wait, what? How is the answer 2? Oh, because, oh my god. It is 2. Huh. Oh, I understand it wrong. Which means the starting point, we have this, and we have this, right? And these can be shot by one of them. We need to find, basically it needs to be the minimum on the yeah, we need to get a minimum of this. Oh, so what you're saying is, okay, so it doesn't really matter. Yeah, it doesn't really matter how we do this. Okay, can we undo all this? Okay, we do this, and no, we don't do current index. We do minimum right. Minimum right shall be points 0, 1, right? And then we say if each one is smaller than min right. Okay, if it's larger than min right, then we need to update this, and then min right will do points I 1. Otherwise, right, we have an otherwise. Otherwise, min right shall equal to math.minimum min right and the current points I and 1. Right, so basically the new one comes, we check if you are within the current range. If you are within the current range, and because we sorted already, okay, we sorted already, so if you're within the current range, then you definitely can be included, right? But after we do that, we have to check your minimum right, right? We check your minimum right, and as we go through everything, your minimum right can change. Right, minimum right is here. The starting point if it's this. And if the next one we include the minimum right gets smaller, then we have to take the smaller value. Right? Okay. Let's try this. Let's try this. Okay, try this. Yep, you have to check the minimum right. How did I not figure this out? Okay, so let's take a look at the solution before. Sorted based on right. Oh, if you sort based on right, you don't have to do the min right. Is that what it is? Yeah, sorted by left, you have to do this. Sorted by right. If it's sorted by right, so the smallest right, and every time you go, oh, it's already the smallest, and the left doesn't really matter that much, right? Ah, yeah. Holy crap. Yep, this is correct. Okay, yeah, that's all right. How did we solve it the first time? 20. I'll do a helper. I do not know what this is, but well, it worked. 2020. That was back then. Okay, so I think finally we have enough Ghana to do this. All right, let's do this problem. So I still remember. See if I still remember. So first of all, we need to compute the prime score of everything. Okay, so we're gonna do prime score of everything. Alright, so first function I need is prime score. Okay, prime score self, give me a number, and we're gonna return an integer. Alright. We need this one to be an integer. Okay, so given n, we need to return prime score. So to do that, we need primes. Okay, so for this, self, right, and self dot primes equals to. All right, so what we need a prime. A number is smaller than 10 to the 5th, right? So 10 to the 5th. If we, what is 10 to the 5th? Square root of 10 to the 5th. 10 to the 5th. Square root 10 to the 5th is 316. I just need all the primes before 316. Okay, so we say primes up to 1000. Okay, great. Is that? No, that's not. Up to 1000. Actually, I don't need up to 1000. Okay, this is actually great. Okay, so self.prime will do this, and we'll do this. Perfect. And all the way to 300. That is good. We just need a little bit more. 316, so we cut to 313. That should be it. All right, so that's that. Right. it's not formatting. I think it's because I didn't install black. Yeah, maybe we should install black. Okay, so let's do this. Pip install black. If I do this, why is it still not formatting? Huh? It's not formatting. I thought I have black, it should be able to format, right? Wait, why? Is it because there's an error, so that's why it's not formatting? I mean, this is not, I'm not even using black. Hold on. It is formatting. It is formatting, but for whatever reason the array is not formatting for me. Yep, it's formatting. I don't know. Honestly, no clue. Oh shoot. Really? What happened? I don't know why. Okay, now you're good. I mean, it's fine. We don't really need a format on this one. Alright, prime score. So for each one, we basically just say for p, right, in prime in self.primes. If n mod p is equal to 0, your score start with 0, and then if that's the case, score plus equal 1, and then while n mod and n mod p equals 0, n divided equal to p. All right, so you do blah blah blah, you get rid of all of them, then you go back up for the next one to check, and then if it's not equal to 0, and this won't run, so you just keep going until the point, well, for p in this, if actually I don't know how to say, if not n, or if n is equal to 1, right? As you do the last one, if n is equal to 1, then you break out. Or actually, if n is either equal to 1, right? If n is equal to 1, you have done everything. or if your p is larger than or you go through everything and then no, I think it's just like this. If your p is larger than n, then we're gonna break, right? Because you divide, and then until a certain point, you remove all the factors. You have the next one, and then you try to check the next prime factor, and if the prime factor you try to check is bigger than where I am, right? If it's not, we just keep checking, and then we go through the whole thing, and then when we get out, we say if p is not equal to 1, right? And then we can just say return score, right? Return score if p is equal to 1, else we need to do score plus 1. Okay, so that is prime score. So the first thing we can say score is equal to self.prime score n for n in nums. Okay, so we create, okay, we don't need this one anymore. So we create an array, right, with all the prime scores. Okay, and then we need to sort, right? No, we do not sort. We create the prime scores, and then what we need to do is for each one, we go from left to right. We will create a monotonic decreasing array. Okay, monotonic decreasing array. As we go from left to right, for each number, we will check its monotonic decreasing on the score. Okay, on the score. And for each new one coming in, I'll look at the left for the monotonic. If my monotonic is bigger, I'll just keep popping until we cannot pop, because it's the requirement is on the left hand side, because it will choose the left. Okay, if the two are the same, and we want to use, I think the one is the, actually I forgot, maximum special platform, and an empty subarray, blah blah blah. Choose an element with the highest prime score. Yeah, we want to choose the highest prime score. So we will do monotonic decreasing. So you will always find the one to your left, which has a bigger prime score, right? It has a bigger prime score than you, and everybody in between is looking at you. So we have its influence, right? That's what we want. Exactly. That is what we want, is the influence, right? Is the influence the current one can have to the left. And we do that, and then, yeah. Why do we need that? I kind of forgot. Because what we want to do is we want a non-empty subarray and choose an element with the highest prime score. If multiple exists, choose the one with the smallest index, and then multiply your score by this x. Here, this is denote. Yeah, so we want to find as many. We want to find as many subarray as possible, right? Max possible after applying at most k operations. Okay, yeah, I want to find a maximum k operations. Non-empty subarray. Haven't chosen, so LR has to be unique, right? LR has to be unique. Okay, so we can choose as many LR as possible, and we need to find LR, not LR, find the maximum LR for each number under consideration. So we do a monotonic decreasing, so we can get on the left hand side, we get every single one, right? We get every single one. So every single one, what I mean every single one is we can get the left bound, right? We get the left bound. We get the left bound. Yes, we can get the left bound. That will be the max we can extend towards the left. Okay. So we have the score. Then we have, what do we have next? find the left bound. Okay, so we say left bound is going to be equal to n equal to lambdas. Okay, so here what we do is times n. Okay, this is the left bound, and monotonic decreasing array is going to be this. Okay, so we're going to go through these number one by one. I mean, for the first one it's done, right? Because the first number, it has to be, the left bound has to be 0 for the first one. There's no question. It's just for the second one, right? So start from the second one. So what we can do is for this, we can just put 0 in it, because this one we're only going to record index. Okay, now we say for I in range, we say 1 to n. Okay, now for every single one, oh hi, so for every single index, what we're gonna do is monotonic decreasing. So we're gonna say while mono and mono minus 1, the top, actually no, well, the scores, right? Scores, because we don't care about the score. So if the score is smaller or equal to the score of the current, okay, so a current one has bigger score, then I'm gonna pop, right? Then we say score, no, mono dot pop, right? When the pop, we keep popping until we hit a score that does not be, is bigger than me, or if we hit someone, not someone, if we hit, there's nobody, right? There's no one else. There's no one else. Okay, so once we're done, we're gonna put in what's the left bound. So we say if mono, I'm doing all right. I did my text today, a very tiring thing. And work-wise, I got a big blocker, so tomorrow will be very interesting. Need to resolve that blocker. So if mono, which means we have something in the monotonic array, then we say left bound I shall equal to mono minus 1, whatever that is, and plus 1. If we don't have mono, we pop everything, then, oh my goodness, then our left bound I will become 0, right? Okay, once we're done with this, mono dot append the current one. All right, so by doing this, we get the left bound of everybody, right? We get the left bound on everybody. Next we're gonna do is we're gonna find the right bound. So it'll be similar. So we say right bound is equal to 0, that's not 0, n minus 1 times n. Yes, this is number 2818. Okay, 2818. I first decided to do this, I think, like what, 5 days ago, 4 or 5 days ago, and then never really got down to it. But I did have an idea, so now I'm trying to implement this idea. Very complex, but I think I have confidence on this one. I do. I have confidence on this one. All right. So for this one, for I in range, again, we can say n minus, actually minus 2, right? We can do minus 2 because I already set the first one down. And then we say, actually, why you do that, right? Why you do this? You don't need to do this. Oh, Jesus. You don't need to do this. Let's just go from the start, right? It's okay. Because this one won't go, and then you will just be 0. Yeah, that's fine. It's totally fine, right? And here's the same thing. Yeah, why do you put this in? You don't have to put this in. I just do this. I do have an account on GitHub. I used to be more active in GitHub than now, I have to admit. All problems? What do you mean by all problems? All right, anyway, so let me focus on this one. So this monotonic decreasing, but it's slightly different, right? Because if I encounter, if I go to the right hand side, right, because it's monotone decreasing, if I go through those, if I find someone who has the same score as me, I can pop it. Oh, shoot. That is not right. We cannot pop it here. For the left hand side, we cannot pop if it's equal. Because if it's equal, it will, because we choose if it equals score, we'll choose the one with the smaller index. Therefore, when we hit someone that's equal, we have to stop. We cannot pop. But on the right hand side, we can pop. So here we can say smaller or equal to score I, right? And then we say mono.pop. This is fine. This is fine. And then again, if mono, then right bound I shall equal to mono minus 1. I intend to say minus 1 here. I intend to say minus 1 because we basically say we hit something that's bigger than us, right? That's bigger than us, then we cannot go. So the extent we can go to is minus 1. Yeah, I do think that is correct. Else, if no mono, then we say right bound I is going to equal to n minus 1. That's the most right we can go. And then mono dot append I. All right, so now we do this, we get a right bound, we get a left bound. Next we need to do is to gather the left bound or right bound and the current nums. We'll sort them. I need the biggest number. Okay, I need the biggest number. So I can say bound combined shall equal to sorted. Okay, we're gonna zip it. Okay, we're gonna zip nums, left bound, and a right bound. I'm pretty sure I can just do it this way. Right? We can zip this. Oh, and then I need to reverse equal to true. Right? So I go big first. Okay. So now after this, what we need to do is go from left to right on this bound combination combined, and to see how much we can compute. We need to keep multiplying, right? We need to keep multiplying. All right, so what we need to do now is to get a mod. So mod is gonna be 10 to the 9th plus 7. That is not a big deal. Now what we're gonna do here is gonna be for number, left bound, right bound in bound combination, not combination, bound combined, and we need to compute how many subarrays we can create from this. Okay, how many subarrays we can create from this. So basically we have the left bound has to go all the way to the current one, right? The left bound has to go here. The right bound has to be from here to there. So for the left bound, I have that many number. For the right bound, I have that many number. That is exactly correct. Okay. So the available shall equal to, damn it, I need to know n as well. Oh, shoot. Damn you, man. Damn you. So I need for I, n, LB, RB, in, and here what we're gonna do is n, LB, RB, and I. Oh, this is complex. It's very complex. So we're gonna do all this, and this. Int is not iterable. Of course it's not, because I forgot to say in enumerate. Okay, so now I have everything. Then I can do index. So available shall equal to I minus left bound plus 1. That's the total number on the left, multiplied by right bound minus I plus 1 around the right. So that's the total number of available. Okay? That is the total number of available. Right? That's the total number of available. And we say if, oh, we need the result as well. So rest shall equal to 1, right? Then we say if, not if, I need to reduce this amount from k, okay? Reduce this amount from k. How do I do that? I should say res equal to res times power, okay, base is n, and it's gonna be available, and it'll be minimum of available and k, and with a mod, and this one will mod as well, and then k shall equal to maximum k minus available, right? Minus available. I might as well just go theoretically. We just say if k is larger than available, okay, then k minus equal to available. Otherwise, if k is smaller equal to, then we'll break, and then we can return res. All right. P is possibly unbound. Oh, that is actually correct. Let's go here. Actually, no, it would not be unbound. Oh, it's not P. Dude, it should be N. My bad. This is N, right? Need type. Okay, that's okay. We can say this is gonna be a list of int. Score is not defined because it's not score, it's scores. Here's the same, it's scores. Oh my god. See, the linting is really useful, and this linting I think is using rough. Yeah, I use rough for this. Okay. Alright. Moment of truth. Do we have this? Nice. We have this one, and let's see. Look at that. Look at that. One shot. One shot. One shot. Oh, I'm so happy. I am so happy. Very, very happy. Very, very happy. Yeah, basically it means this method is correct, right? This method. I mean, if you want to really simplify it or not, and there are definitely ways to make it a little bit better, but I'm happy. Very happy about this. Very happy about this. One of the best I've done, honestly. Well, it worked. First shot. First attempt, right? I'm very happy. This is a monotonic array. Decreasing array, actually, right? Decreasing array. We use that to find the left and right bound that each number can extend, right? Can extend. All subarrays within these within this range, use the number, right? Use the target number, use the current number, right, as its number for multiplication, right? For multiplication. In other words, all the other numbers, right, within the range have smaller or equal if it is on the right hand side, have smaller score, prime score, right, prime score than the target, than the current number. Once we find all the ranges, find the ranges for all the numbers, find the ranges for all the numbers, we only need to pick the largest number and exhaust all its possible subarrays, right? If there is still, right, there is still k left, we move on to the second largest number, and so on and so forth. So O(n) log n for sorting, right? O(n) log n for sorting, and everything else just works. Oh, look at that. Now you do, huh? Now you do. Oh, man. I don't even know what to say. Okay. Good problem. Let's see the hints. Calculate the prime score. Yes. For each number, find the nearest left such that, yes. Monotonic stack. Yes. Then the maximum value in the range. Yes. Yes. By none increasing. Yes. Yes. Fast explanation. Yes. Good problem. Very good problem. Day 500. Number of subarrays. Okay. Alright, we can move on. That's great. Awesome. Oh my god, all these I cannot do. Okay, this is the next one. Alright, that'll be it. Good. Very happy. Alright, I'll see you guys tomorrow. Adios.